the string here is cut and it falls, and this dart at the same exact time that the string is cut is launched at this velocity at this angle, right? And so your job is to find h. So, the path of the dart isn't going to be straight, even if it's aimed. It's going to rise to some height and then fall. And you want to find out, like, what if they're going to collide according to this graph, right? This is the collision time right here, right, at this end point. And they tell you that these areas are the same. This area is going to be the same as this area. So how do you use this information to figure out? So, I'm not sure. So let's see if we can do process of elimination, which is a very useful tool for this kind of problem, because they're not asking for numbers. Find the area under the curve for the dart. The area under the curve for the dart, this area, this will give you the distance, or the displacement, sorry, of the dart. Right, so it's going to give you from here to here, right? This distance from the beginning to the end only. So this is what A is going to show you. That's not going to give you h directly. So let's keep going. Find twice the area under the curve for the dart's data. I'm not sure about that one, so let's skip it for now. We know that the area under the curve for the dart is the displacement, but let's see. Find the slope of the curve for the dart's data. Well, the slope is going to be, right, this is a velocity versus time graph. That's going to be acceleration. So that's not going to get you a distance at all. Find twice the slope of the curve for the dart's data. Well, if the slope is acceleration, that's not going to help at all. So because you've got this being the displacement of the dart's path, and that's not going to give you the displacement of here. That's only from here, from where it starts to where it ends. So this is traveling halfway, right? And then back down. Well, then this has got to be double, right? So to get double the displacement, you have to multiply the area by 2. So you end up with B as the correct answer. So let's do another one. Which of the following graphs could represent the vertical component of the velocity as a function of time for the dart and the target immediately after the dart is launched and the target begins to fall? So looking at these different graphs, we've got 4 of them here. So these are the dart, and this is the target. So when the target these are velocity, should mark that down, and right, all this is our vertical velocities, okay? So vertical velocity for the dart, initially, right, it starts with a positive velocity, right? And then it's going to decrease its speed until it gets to some maximum height. And it's moving in the positive direction. So this isn't right because it says it's starting at rest. So this can't be true. This is not starting at rest. So it's either A or it's D, right? Those look pretty much the same. Then we've got for the target, so it can't be this one or this one. So we're just really looking at these 2 now. So now we're looking at the target. Here it says this is a positive velocity to start with. This is a velocity of 0 to start with. So the target starts with an initial velocity of 0, so it's got to be D. So really using process of elimination is very useful in these cases. So let's look at 13. So 13 has a displacement of the dart and the displacement of the target. So the question is asking you to evaluate which way, it says which displacement component, the horizontal or the vertical, is represented by the graph. So for this one here, we know the target, the dart, starts here, right? The dart starts here and it's launched. right? And here, the target is here and it falls down. It has no horizontal displacement. So the target must be vertical, because if it was a zero displacement, it would just be a horizontal line. So we can then eliminate for the target anything that says horizontal. So we're left with C and D. So then we're going to look at the dart, right? And we know here we've got a position starting at 0 and we're ending with a positive displacement. So, but it's not only is it a positive displacement, but it's a changing velocity, right? Because the slope of a position time graph is your velocity and the slope is changing, right? It's positive and changing. Therefore, the velocity is positive and changing, right? And it's actually slowing down, not just changing, but it's decreasing. So we're decreasing our velocity. So what must that be? Well, we know, right, that in this direction, on the horizontal for a projectile, we have velocity is constant. It's a positive value, but it's a constant speed. On the vertical, we have we are starting here and we're going up, so we're decreasing our speed because it's going to slow down as you go higher and higher. So this must be vertical as well. So that gives us an answer of D.